So, philosophy of mind. It's basically what you would get if you ask someone to create the most difficult topic to discuss possible. You've got all these subtly different questions. You've got the fact that we don't understand how neurons work together in anything larger than a small cluster. Add on to that, that science still has no idea how exactly consciousness arises. And you've got a topic where answers require knowledge that we just don't know. But why let a little missing knowledge get in the way of an interesting philosophical debate? So let's start with some quick definitions. First is strong AI. Strong AI, as defined by John Searle, who has some other ideas that'll come up a little bit later, is the position that a sufficiently powerful computer, when programmed correctly, literally understands and thinks like we do. In other words, you have a really smart programmer. If you give him a really big computer, then you could have a mind. Weak AI, on the other hand, is a more conservative position that says that computers might exhibit intelligence, if it can even be called that, but they'll never have a mind of their own. Next, there's the Turing test. For a computer to pass the Turing test, it needs to be able to fool a human judge into thinking that it's human. To run it, you hide a computer and human away in the room. Then in another room, you have a human judge. Now you have the human judge talk to the robot and the human through some electronic system, so he can't just look at them. And if he cannot reliably tell them apart, the machine is said to pass the Turing test. Finally, although it's not exactly a definition, is the distinction between the brain and the mind. Now, this distinction is a little controversial, but it's still important not to be sloppy, even if you think they're the same thing. The brain is an organ. You can measure it, you can perform surgery on it, you can run MRI scans on it. It's a physical object. The mind, on the other hand, is a little more nebulous. For now, though, let's just say it's a thinking entity that has three things. It has to have agency, it has to be able to understand, and it needs to be conscious. Now, in some sense, the ability to understand things is actually a form of agency in and of itself. Even if you couldn't do anything, how you interpret information, or the lack thereof, would itself be a sort of decision. So I think it's fair to say that understanding is sufficient for agency. In other words, once you have understanding, you have agency. And so that brings the requirements for a mind down to two things. And let's start with the ability to understand. Can a machine know stuff? This is the first layer we're going to peel off as we try and get to the center of the debate around mechanical minds. So let's look at some examples to see if we can pin down what's necessary for knowledge. First, as an example I hope is common ground, does a picture of a bear know what a bear looks like in the same sense that you or I know what a bear looks like? I think the answer here is a hard no. A depiction of a bear doesn't understand what a bear is. Okay, does a compass know where the North Pole is? Again, no in the same sense that you or I know. Again, probably not. This is a little bit different though, since a compass can be wrong. Say if you have magnets in your pocket. Some philosophers have even said that the ability to be wrong is essential to a mind. The issue here, though, is that we give the compass meaning. It can't be wrong without us. A mind, on the other hand, can be wrong without some external source of meaning. So still, no understanding. Here's where things get a little bit fuzzy, though. Does a basic analog thermostat know when it's too hot? Now, this is a little more interesting because the thermostat has some amount of agency. If it thinks it's too hot, then it can do something about that. And I've even heard of people talking about thermostats as understanding. And you should consider for yourself what you think, but personally, I don't subscribe to that idea. While understanding may be sufficient for agency, I don't think that works the other way around. Newer thermostats, like say the Nest thermostats that learn your schedule, are getting closer, but they still don't understand what heat is or what a heater is like. They can't be said to understand those things. Okay, finally, do calculators know how to solve equations? Now, a calculator has the ability to solve problems, but is that enough to have knowledge, like in the same sense that we have knowledge? I'm inclined to say no to this one too, since it doesn't understand addition, even if it can do it. One could argue that the logic circuits in the calculator are all there is to addition. But that's not what addition is about. Addition is about combining two sets of things. It's about putting stuff together, not following rules, even if that's how you do it. Imagine aliens who don't eat food came to Earth and followed a cookbook. They might be able to bake a cake, but they don't understand what the purpose of cooking is, or what the result of cooking is, or why people would do it. They might be able to cook, but not understand cooking. Similarly, a calculator might be able to add, but it doesn't understand addition. It should be noted, however, that these machines have some aspects of understanding. There's a sort of gap between how they understand and how we understand. The question is, what is necessary to fill that gap? And I think to fully bridge the gap between mechanical understanding and real understanding, we need consciousness. It seems like consciousness might be necessary, or maybe even sufficient for, understanding. So, can computers be conscious? Recall that strong AI is the position that says that computers can have minds. Now, arguments for strong AI usually rest on the following analogy. For strong AI, the brain is like the hardware, and the mind is like the software or the program. Using this analogy, it seems totally natural that we could run the mind program on mechanical hardware. It's just swapping brain hardware for mechanical hardware. And if you're not convinced by that, what if we just simulated the brain? If we simulate it down to the smallest relevant detail, then wouldn't you have a mind? This seems like a pretty watertight argument. Some people seem to disagree, so let's hear what they have to say. The first counterargument I'd like to look at was created by John Lucas and further developed by Roger Penrose. It tries to use math and logic to prove that human minds can't be replicated on computers. And if using math sounds weird to you, you're absolutely right. It's super weird. And although the consensus is that it doesn't hold up, it's an interesting argument nonetheless. Here's a sketch of the argument. We start off with a fairly innocuous assumption. We assume that all mathematicians use the same valid algorithm to determine whether or not proofs are valid. Let me repeat that. So you've got your mathematicians here and your mathematicians over here. They both are using the same method to make sure that proofs really work. Seems like a fair assumption. Okay, next, let's suppose for the sake of the argument that a human's proof judging ability could be put into a computer with no differences. Next, we use Gödel's incompleteness theorem or something similar to construct a true statement that the machine with the human proof judging abilities can't prove. But then we can see that it's true, and that's a contradiction. Now, it's a little hard to explain how it can be clear that the machine can't prove the statement, but the human can, without going to a bunch of math. So take my word for it that it isn't necessarily impossible. And you can, since, for example, you can use the machine in the statement, and that can help you make it something that the machine can't prove, but you can. Anyway, we found a contradiction, and we conclude that our earlier assumption that the human proof-checking abilities were digitizable was false. Now, this specific argument has been subject to a lot of criticism. In fact, I want to show you a line from a paper that claims to have found a hole in this argument. Just take a moment to read this because papers don't get much more interesting. So yeah, some people are pretty convinced he's wrong. But in some sense, what he's doing is more interesting than how he does it. He's trying to use math to find a limitation on computers that humans don't have. He's getting at the idea that computers are inherently mathematical, and then using this to show that humans aren't like that. And you should consider whether or not using math to answer these questions is doomed to fail from the start, or whether we might actually be able to use math to answer some of these. So in his books, he provides another useful idea, though. Remember how proponents of strong AI would suggest that we can simply simulate the smallest relevant detail and get a mind? Well, Penrose hypothesizes that this argument doesn't work because quantum mechanics may play a role in consciousness. You see, quantum mechanics is random, and digital computers are limited to pseudo-random number generation. So if quantum mechanics plays a role in consciousness, the argument about simulating smaller and smaller details falls apart because machines can't be truly random. But the truth is, though, we just don't know enough about the brain right now to say for certain whether this is the case. The second counterargument to the strong AI position is a thought experiment devised by John Searle. It's called the Chinese room. Imagine you're a non-Chinese speaker sitting in a room. In there with you is a book containing some rules written in English and a computer screen. Every day, you manipulate the Chinese symbols on your screen according to the rules in this book, and then output a final string of Chinese symbols. Searle posits that this is exactly what computers do when they interact with the outside world. This room could, for instance, pass the Turing test for speaking Chinese. It could seem like it understands Chinese, but as Searle wants you to notice, the person inside the room does not understand a word of Chinese. They're just following rules in a book. And thus, Searle wants us to conclude that digital computers, which are just formal symbol manipulators, will never have a mind or understand things in any way remotely like what we do. There's one counter argument that I'd like to quickly get out of the way since it has a fairly trivial response. It's what Searle calls the systems reply. It basically says that while the human in the room doesn't understand a word of Chinese, the person and the room and the rule book all combined do understand Chinese. The simple reply to this counter argument is just throw out the book, have them memorize it, put them in a field, no book, no room. Now the person is the entire system, still doesn't understand Chinese. It's important to note that he might seem like he understands Chinese, but again, he does not. He might even be able to pass the Turing test. And it's actually worth looking a little bit more at what the Turing test can do. While some might think that the Turing test evaluates consciousness, it doesn't, and neither can anything else really. It's important to realize that the Turing test only tests how well a computer can fool a human and how human-like it can act. It doesn't verify whether you're conscious or actually understand stuff. How a system arrives at what it does is just as important as what it actually does. The Turing test looks at the latter, but what we care about is the former. So consider, for example, the thought experiment about philosophy zombies. A philosophy zombie is human in every way except that they're not conscious. They pass the Turing test and they tell you that they're conscious, but they're not. And this leads to the important observation that consciousness is what we call private. That means there's no external way for you to verify, for example, whether I'm conscious. Only a first-person observer, like me, can verify whether or not I'm conscious. Does that mean that the Turing test is useless? Absolutely not. It's a great way to gauge intelligence. It just doesn't test understanding or consciousness. We actually have a neural network already, GPT-3, which passes the Turing test. Well, okay, it only passes the Turing test for poetry, so it can fool you into thinking that it gives you human poetry, but so don't get too excited about it. But still, GPT-3 deserves a little bit of credit. It's the successor to GPT-2, which was basically what would happen if you said, you know how we have neural networks? What if we made a really big one? So they made that, and it was pretty cool. You may have heard about its article concerning the discovery of unicorns that it generated all on its own, or maybe the concerns about it being used to create fake news. Anyway, GPT-3 happened when someone said, you know how we made a really big AI and it was pretty cool? What if we made an even bigger one? And so GPT-3 was born. Now, GPT-3 has done some pretty amazing stuff. Obviously, there's the aforementioned ability to write human-level poetry. It also, however, can solve math equations it's never seen before. Now, you might be thinking, well, my calculator can solve math equations it's never seen before. What's so special about that? The reason this is so amazing, though, is that it was trained to process language, not math. It would be like reading every book in a library to improve your reading ability and coming out able to do addition. You could probably do this. It's what we call learning. And yet GPT-3 has also managed to learn for some definition of learn. And that's pretty impressive. This was also all done recently, so we're just beginning to see the power of AI in action. I guess what this gets at is that there's a lot, and so far we've come pretty far as well. There's one final thing I want to leave you with. So we've been asking, can digital computers have human minds? But what if machines could have minds in a different way than we do? Jet planes and birds both fly, but they fly in very different ways. Jet planes, use thrusters, and birds flap their wings. Maybe it's possible for humans and machines to both have minds, but not in the same way. It's an idea that doesn't usually get much consideration, but I think it's especially interesting since it stays in current technology and also avoids unknown neuroscience. It allows us to sort of answer a question without having so much speculation.